Hi there. Thanks again for joining us. This is Space Nuts. My name is Andrew Dunkley. Looking forward to your company for the next little while where we be talking astronomy and space science. And on this episode, we've found a weird rock on Mars. It just sort of stands out like a pustule on a face. And that's kind of what it looks like. Also, an unusual side effect to space travel, and it's a positive one, sort of. And the James Webb Space Telescope in the news again. It's spotted an asteroid collision. We'll talk about all of that soon on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here to unravel it all is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Not very large at the moment. I'm sitting at home. But I'll be at large this weekend. Yes.
No, it's good to see you. I've just come back from a little sojourn to China and had a fabulous time. And what a lovely country. Beautiful people, really nice people, and it was the one of the time frames we were there was the weekend of a public holiday, a national public holiday, the Dragon Boat Festival. They basically shut down everything for the week, and it brings people from the far north of China down into the big cities. And we were warned that a lot of them have never seen Westerners in real life before, and we could expect some weird interactions. And sure enough, especially people like my wife who are blue-eyed and blonde, got mobbed, absolutely mobbed.
Really?
Photos, yeah. There was one stage there, she's sitting down and 3 women just converged on her, sat down, hugged her and got their photo taken. And at one point, this is hilarious, they pushed one of the men who was a bit too shy over to sit with my wife for a photo. It was amazing. Yeah, and sneaky photos being taken of us all the time as we travel around the country. You don't think about it really. You're so used to the way things are with us. Everybody knows everybody kind of, but in China there's still a lot of people who've never seen a white person up front, and it really excited them. It's nice to be able to excite people for some reason or another. But terrific trip. Got to see so much. Climbed the Great Wall. Nearly killed me. Went to Tiananmen Square just after the anniversary of that fateful day in 1989. Security was very tight, but what an amazing place. And I went to the Terracotta Warriors, Fred, which was an optional tour. And I thought, we're here. We can't not do it. And it was the best thing I did. It's just, we were gobsmacked. It was like a rugby scrum of 20,000 people to get in there and have a look. But it's just amazing. Just amazing.
It's enclosed in a building, isn't it? The site there. Yeah. And this is fully excavated now.
No.
No, okay.
That's just one pit of 3 that they've opened up. It's the biggest. It's probably an area the size of a soccer stadium that's undercover, with all the soldiers lined up in the pits. But they told us there are 600 of those pits surrounding the tomb of the emperor. So there's still a lot to discover out there. Incredible,
extraordinary. Just extraordinary.
Yeah. But lovely people, and I think one of our favourite nights was going out to have a meal and finding a place called a hot pot where it's like a sushi train. The food just goes around on a conveyor belt, but you've got to cook it yourself. And we didn't have a clue what to do, and no one spoke English. And the family next to us was so lovely and helpful, and we talked with Google Translate. And it worked over there, believe it or not, because Google is not usually something that works in China, but we had a terrific time. Yeah, terrific time. Highly recommend it. Now, Fred, we better get down to business. They've found a weird rock on Mars, and this is another discovery by the rover that's basically wandering around looking for signs of past life on Mars, but it's looking at rocks as well. And this is a curious discovery because it sort of stands out like a sore thumb or a pimple, this one.
It's really remarkable when you see the image that's come back. It's the Perseverance rover, which is at Jezero Crater, and it's been exploring the river delta that used to represent flow of water into the crater, probably 3 billion years or so ago. And there's a remarkable image that's been sent back by Perseverance, which shows sort of a hillside, which is strewn with boulders, all of which are dark in colour, except one that stands out vividly as being much, much lighter in shade. And it's actually textured as well. It's not just sort of white looking, but it's got texture through it. And it has been identified as something called an anorthosite. I hope I'm saying it right, anorthosite, which is a rock that's currently found, or that we believe has come from the crust of a rocky planet, fairly deep in the crust. Now, these things are quite common. Anorthosite's quite common on Earth and on the Moon as well, but are thought to be very rare elsewhere in the solar system. And so this has certainly caused, a great deal of interest among the Perseverance mission controllers, and it's basically one that will be the subject of further research. Although, curiously, what they haven't done is gone up to it and taken samples of the rock, and that is because the mission team believes that there will be more of these anorthosites in the rim of the Jezero crater, which is kind of where they're heading for. And so they expect to see many more of them. And the reason for that, Andrew, is that if these things are rocks that have come from fairly deep in the crust of Mars, the Jezero crater is an impact crater. It's an ancient impact crater which was caused by probably a small asteroid hitting the surface of Mars, maybe 3.5, getting on for 4 billion years ago. And the thinking is that they're likely to find these remnant rocks from the crust around the rim of the crater. So rather than sort of spend time analysing this particular one, they are expecting to see more as they traverse up the rim of the crater. But if they don't, they'll come back and have a look at this anorthosite, which, by the way, has been given the name of Atuco Point, which is one of the landmarks of the Grand Canyon.
Ah, of course. Well, that makes perfect sense. It does stand out. I mean, when you look at the landscape, the soil is, or the regolith is red. The rocks are mainly reddish to greyish, but this one is white. It looks like a big hunk of chalk, really.
It does. It's actually a mineral called feldspar, which is one well known on Earth, linked to lava flows, and it's white because of its rich silica content. The other ones are probably basalts, the darker rocks. But yes, as I said, the anorthosite is feldspar.
Well, basalt, that's as common as dirt, isn't it?
Well, it is dirt. That's what makes dirt, yeah. When it's worn down, it turns into dirt. Yeah, and of course, basalt's a volcanic rock. Yeah. Well,
this is somewhat volcanic, isn't it? From what I've read, it's got a... I read the definition: the granitic magmas appear to be produced by partial melting of lower crustal rocks.
Yeah, so that's right. Volcanism's involved, but it's definitely lava flow stuff rather than volcano stuff, if I can put it that way. So it'd be really interesting. Sorry, go ahead, Andrew.
I was going to say my first thought when I saw it was pumice.
Yes, that's a really interesting comparison, because you're absolutely right. It does look like, it looks a bit more solid than pumice, if I can put it that way. Pumice, of course, is, again, it's volcanic rock that's been that's been exuded from the Earth in water, and so you get all the steam, that was formed, creating the voids in pumice. So it does look a bit like pumice, but perhaps only in its colour. The close-up of the rock that I've seen, it does look quite solid. It's got a hard edge to it that looks as though, it's broken at some point. There must be another half of it somewhere or something like that. Very interesting. And I think what we should be looking out for is future mention of these anorthosites when they are found, or if they're found on the rim of the Jezero crater.
Yeah, well, the funny thing will be, not funny thing will be if they get to the rim of Jezero crater and don't find any and go, we should have just, should have done that.
Should have done it. Should have done it. Core samples are what you think of. But they said, the comments that I've read, if they don't find them on the rim, they're going to come back and actually start digging into this one. So we'll see more of its contents.
Yes, indeed. And it certainly will give us a little bit more information to work with in terms of the history of the red planet with white specks. Now... Yeah. Fred, let's move on to a really interesting story about space travel and health. Now, we've talked about space travel in the past and how it can have negative effects on the human body, muscle wastage, bone wastage, particularly with male astronauts, potential damage to the eyes. But this story goes back a couple of years to a civilian mission which was aimed at looking at the effects of space travel on the human body. And what they discovered is astounding.
Yes, it is. The bottom line is that, space travel is bad for your health in some of the things that it does, but you recover very quickly. When you get back to Earth. That's one of the findings. So the backstory is exactly as you've said, Andrew. This goes back to September 2021, when there was a mission which was carried out using one of the Crew Dragon spacecraft that manufactured by SpaceX, and it was for astronauts who were effectively space tourists. They weren't people who'd had years of training and years of physical preparation to get them ready for a space flight. They were just ordinary people. They probably had a little bit of training. It was funded by a billionaire who was one of the people who rode on the trip. And as I said, they flew in Crew Dragon for almost 3 days. So this wasn't a space flight that linked with the International Space Station. They were in the capsule for those 3 days. What I didn't know until I read up on this, to talk to you about it, I didn't know that the docking port on the spacecraft. So you remember the Crew Dragon, a lot like the old Apollo spacecraft. They're conical in shape, and at the nose end there is a doorway, and that's basically what you essentially dock into the International Space Station with, and can transfer astronauts through the doorway into the space station. So that wasn't needed because they were never going to be anywhere near the space station. In fact, they weren't quite high, higher in space, I think about 600 kilometers than the space station space station's at about 400 kilometers. And so rather than have just a wasted door that wasn't going to be used, they had a transparent window, a kind of cupola, a sort of miniature of the one that's on the International Space Station. And so they got some brilliant views of Earth from orbit. But cutting to the story itself, one of those astronauts, which is, I guess, what they were because they were flying in space, whose name is, I think I'm pronouncing this correctly, Haley Arsenault, is a doctor, effectively, or certainly has training in medical science. And she was basically the medical specialist on the flight. And for the 3 days, she took pretty regular blood samples, in fact, biopsy samples from skin, samples that were designed to show what the short-term effects of space flight are, given that this was only a 3-day mission. But the fact that they had so many samples taken meant that there was a treasure trove of medical information which was brought back with these astronauts. And what's happened is that they were distributed to more than 100 institutions all around the world in order to do an analysis of all of these things. And in fact, there was a kind of special issue of the journal Nature last week, which presented several papers which were related to exactly this. And so one of the things that these data show is that it's within a few hours of you being in space in weightless conditions, your body starts changing. And those changes are fairly rapid. They're basically to do with the changes in your blood. There's changes to your skin, the proteins, your kidneys, your genetic makeup changes slightly. All sorts of other health indicators actually change very quickly. But as I mentioned a minute ago, something like 95% of these changes come back to normal within 3 months. One that, and I think this is the one that you're really referring to, that it's an astonishing one, is to do with the telomeres, which are the caps on the ends of chromosomes. They've been likened to the little caps on the ends of a shoelace. So telomeres are, they're an important part of our makeup at a microscopic level. And they normally, what happens as you age, the telomeres, in fact, they shorten. Actually, phys.org have got a typo there in their article about this because it says they lengthen as you age, and they don't, they shorten. But what happened within, almost hours of these astronauts being in space, they started lengthening. So that it's almost like time running backwards. The telomeres actually started lengthening. And they, they're an indicator of your well-being, your longevity and things of that sort. So that was really quite remarkable. When they got back to Earth, they started shortening again, the telomeres, and they shortened just rather more than they would have done had they not gone into space. So when they were in space, there was this reaction by the body that was almost like reversing aging. They caught up with it when they got back to Earth. The telomeres shrunk back to their original length.
Wow. I mean, I'm looking at some of the wording that's been used in the story, and anti-aging and reversing the that sort of thing, which is probably a little bit of creative license. But could this be studied? Could we learn something from this, perhaps?
Well, that's right. That's exactly what has come out of this. Whether you could have face creams or something like that, or skin creams that would rejuvenate your body to its youthful appearance.
I've got an idea. I've got an idea. Look, this is happening in space. Space is sort of a big void. So I think if we just sold empty jars to people and said, rub this on your face, we could make a mint. The problem is, and I've struggled with this, Andrew, is getting zero gravity into a jar. That really is quite tricky. Maybe you could take a jar up into space, open it in space, then seal it again and bring it back. What would happen then?
You just get some of the mouldy air from the International Space Station or whatever that you're bringing back. Apparently, Mir was the worst one. Mir, the space station that preceded the International Space Station, a Russian venture. Apparently, that was not very wholesome by the time it was finished its occupancy, which I think was in the early 2000s, late 1990s actually.
Maybe they could use the robotic arm to take the jar out, take the lid off, then put the lid back on, and then you've got space in a jar.
Yes, you do. Yeah, you've got a jar with a vacuum in it. But as I said, the really important thing in this study is getting rid of gravity, and that's a lot harder.
Yeah, that's the problem, isn't it? It's the zero G. Maybe the day will come years and years from now where they will have hospitals in space for people who can gain benefit from zero G.
Or even health resorts, Yes.
Yeah, you never know.
Yeah.
I think that's a distinct possibility, but they were fascinating findings, and if you want to read about them, you can go to the phys.org, phys.org website. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a quick break from the show to talk about our sponsor, NordVPN. And as you probably heard, I've just come back from overseas with Judy, doing a trip throughout China. And of course, in China, you do have restrictions on access to the internet, particularly the likes of Google and Facebook and WhatsApp and a few others. You can't use them unless you have a VPN. Now, this is in a Wi-Fi scenario. You can access a little bit more when you're using your mobile phone in the normal scheme of things. But if you're using Wi-Fi, you generally are restricted. So NordVPN was extremely useful in that regard, and so very helpful to enable me to access stuff that I normally access at home day to day that I couldn't get to without a VPN in China. Now, our sponsor has got some great deals going and some exclusive deals for Space Nuts listeners. And as I've mentioned many times, you can sign up for all sorts of different levels of service over different periods of time, depending on what you need and what sort of price you're willing to pay. You can get a big discount at the moment, which we've talked about before, 4 extra months when you sign up. But here's an interesting little bonus that they've got on offer at the moment for a short time. It's an eSIM data. If you buy any 2-year NordVPN plan, you can get up to 10 gigabytes of free mobile data on Saily. And that's a global eSIM application for travellers. When you do travel, sometimes an eSIM is the way to go. I had to do that in Egypt because my service provider didn't actually offer international roaming in Egypt. So I got an eSIM. To be able to get 10 gig for travel for free, that is awesome. That's plenty of data. So it depends on your plan, but you will be rewarded with 1 to 3 gig or up to 10 gig of mobile data, which you can use in 150 different countries around the world. And you'll receive your Saily voucher right after your NordVPN plan is purchased. So there's something else to consider, as well as all the other remarkable tools that are available through a NordVPN subscription, such as your high-speed virtual private network, which I've done speed tests on in the past, if you've heard them, and they are incredibly fast. In fact, I found they were faster than my direct connection to my internet service provider. You can secure 10 devices at once through a Nord plan. That's on all levels of plan. But if you want to go the extra mile and get malware protection and the ad blocker and the tracker software, there's a plan for that. Or if you want to get everything, which adds on the cross-platform password manager, the data breach scanner, and 1 terabyte of encrypted cloud storage, you go for the top-notch plan. Now, if you buy it over a longer period of time, the price goes down on a month-by-month basis. The best way to choose what you want is to log on through our special URL and have a look at the different options. But certainly a good time to get NordVPN with that eSIM data package available for a limited time only. So the URL is nordvpn.com/spacenuts. That's nordvpn.com/spacenuts. Check it all out and see what works for you. They have been fabulous supporters of us, and look, honestly, they are the best in the business when it comes to virtual private networks and all those other amazing tools. The cross-platform password manager, I would buy that on its own. It is the best thing since sliced bread. That's nordvpn.com/spacenuts. Check it out today. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now to our final story, Fred, and this one is involving something we never talk about, the James Webb Space Telescope. What I find really interesting about this story is that it has observed something a long way away that is probably very difficult to witness, even if you're standing right in front of it. Although you wouldn't want to.
That's right. Yes, so it's a very clever piece of, detective work, and that's kind of what astronomy is all about. And it concerns a star which rejoices in the name of Beta Pictoris, which is a young star. It's only about 20 million years old, so it's very much in its infancy. And it's surrounded by a disk of dust. Now, dust is the raw material of planets, and we call it dust, but it's kind of in many ways better to imagine smoke, because that's more or less what it's like. And it's circulating around this star. But the story goes back actually to 2005, when another infrared spacecraft called Spitzer, another of NASA's great observatories, that was used to observe Beta Pictoris and sort of analyze the disk of dust. And they found one section of the disk that was very rich in a particular kind of dust silicates of a certain type, which basically revealed that there was different sorts of dust in this particular part of the disk, of the dust disk, and there wasn't really an understanding of what was causing that. It was the analysis of the spectrum of the dust with infrared, which you can do, that showed these particular peaks that came from, a certain type of dust, and that was presented in the literature, but not really analysed in depth. So now move forward to today, and the James Webb Space Telescope, which has looked at the same bit of the Beta Pictoris dusty disk and finds no trace of that earlier dust that was revealed by Spitzer. And so what they're suggesting, this is very, very fine dust, apparently, that we're talking about here. What they're suggesting, and this is scientists, by the way, from Johns Hopkins University in the United States, they're suggesting that what we were seeing back in 2005 was the debris from a collision of baby asteroids, which are resident in that dusty disk. So they actually probably not that small. The asteroids, they think, were probably 100,000 times bigger than the asteroid that wiped out the dinosaurs. So they're fairly substantial, but they are still asteroidal. They're not planets. They're small objects which are probably, the precursors to planets, because we think that planetary formation is something that starts small and builds up gradually. So what they're saying is that the dust that was seen in 2005 was from a collision of asteroids. And the reason why we don't see it now is because it's been blown away by the radiation from the star itself. The solar wind from Beta Pictoris itself has cleared that area of this very fine dust that was seen before. And that is why this interpretation has been arrived at by the Johns Hopkins University team. There's not really any other explanation for why you should see these dust particles at one time and then nearly 20 years later, find they've gone altogether. And so, yes, they have a cogent story to tell, and it illustrates just how wild early solar systems are, because that's what we think happened in our solar system. There's a gradual build-up of objects, but that was often interrupted by collisions between these objects, and exactly like we think has occurred in Beta Pictoris. which, just to tie up the loose end, it is, yes, it's a long way away as the crow flies if you're walking, but it's relatively close star. It's 63.4 light years from our solar system, so it's within the solar neighbourhood, within the sun's neighbourhood.
You and I have talked about how our solar system and the planets themselves were probably created early in our existence, and that happened a long, long time ago. Is it fair to say that what we're seeing here is the same process, but we're catching it at a much earlier stage in that solar system, something we obviously could never have witnessed here? And if that system goes on to develop intelligent life, they'll not have witnessed it either, but we have. Yes,
that's right. And there's a precursor, actually, just thinking back, and I think this is a story that we covered probably a year or so ago. There's a star called Fomalhaut, Fomalhaut, I think it's spelt, which also has a dusty disk around it. And for a while, what was thought to be a planet was being observed in that disk by, I can't remember which telescope. I don't think it was the JWST. I think that was before the Webb telescope came into action. But that planet seemed to be swelling up, but it eventually dispersed. Again, it was thought that what had been seen there was the result of a collision. You have a cloud of dust that's the debris from something that's been collided with, and that eventually disperses and disappears. I think the headline we had was the disappearing planet, because it was originally thought to be a planet and eventually dispersed and wasn't there anymore. I think that's what we talked about.
And this is a similar situation. What surprised me in regard to this story, Fred, though, was like they've made the early observations of the collision, and the follow-up pictures were only 20 years later-ish, and the dust is gone. It's you don't think about things happening that fast in solar system formation.
With a collision, though, yes, I think you would. We've seen colliding asteroids in our own solar system, and the debris takes not very long to disperse. What usually happens is, because what you're seeing is lots of debris being illuminated by the sun. As that debris spreads apart, it becomes less and less obvious. You can't see the individual bits of debris. All you can see is the effect of the cloud itself. And so it just gradually gets fainter and fainter as the cloud gets more dispersed.
I suppose if we just sort of set our watches and wait another 30 or 40 million years, we might be able to see what it turns into.
Yeah, we might. Yeah, or maybe even 200 to 300 million years, we might see what it's turning into.
Who knows? I don't know. Yeah, but it's certainly proving what a great tool the James Webb Space Telescope has become. It's just doing exactly what they promised. It's finding these things that we couldn't have hoped to have seen 20 or 30 years ago, and giving us so much data to work with and so much information. I bet you'd love to get your talents into the James Webb Space Telescope, Fred.
No, I don't think I'm clever enough to write a proposal to do that. What I'd have to do is what I've tended to do for a long time. That's tag along with a lot of other very clever people who've got the ideas, and I can kind of help in some way or another.
Yeah. But gosh, so much more to discover. But it's of course, it's throwing up new questions with all the things that it sees. But it's also coming up with a few answers.
That's right. And you're absolutely right. What you just said before. It's so many different bits of astronomy, different problems that we're looking at, different questions that we want answered on a vastly different scale. Because at the same time as it's doing all this, it's also looking at some of the youngest galaxies that we've ever seen in the universe, when they're only 290 million years. The universe is only 290 million years old. It's an extraordinary tool. You're absolutely right.
Yeah, incredible. All right. If you want to chase up that story, it is at the space.com website, and definitely a great read to observe something so far away and learn what's happening and sort of correlate it to what our early solar system went through. It's a it's a revelation. Although we knew it happened to us, but now we've got physical proof. Fred, that's just about it for another week. Thank you very much.
It's a great pleasure, Andrew. Nice to see you back home in sunny Australia, and we'll talk again soon.
We will indeed. Professor Fred Watson, astronomer at large. Don't forget, though, if you're on social media, don't forget to follow us on Facebook and Instagram, or the Space Nuts podcast group, where you can talk to each other and share photos and stories. And don't forget to visit our website. And if you're a YouTube follower, don't forget to subscribe. We really appreciate that. And we welcome your reviews on whatever platform you use. And thanks to Hugh in the studio, who's had a long weekend. And from me, Andrew Dunkley, catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.